under root a square minus x square, this integral, and the direct result after integrating this is x by 2 under root a square minus a square plus a square by 2 sin inverse x by a plus c. Now the result is okay, but how actually we have got to this result? That is, integration of u dot v, u is the first function, v is the second function. So the result will be u integration of v, that is the integration of v with respect to dx, minus integration of differentiation d by dx of the first function, which is u, and the integration of the second function. Now when you multiply these two, then the result will be dx, that is one more time we'll be integrating it. So we have this under root a square minus x square. So integration of a square minus x square, how are we going to go about it? What are going to be the steps? So you know already that root x is equal to x to the power half, x raised half. So we'll do it by the integration by parts. So we'll assume that 1 is already there. We don't have to assume because 1 is already multiplied by every number. Now we'll take the first function as under root a square minus x square and second function as 1, as I indicated you in integration of u dot v, the formula we are going to use just now. So the first is under root a square minus x square, integration of 1 dx minus integration of now the differentiation of the first function, which is under root a square minus x square, then the integration of 1 dx, and then final multiplication of these two, differentiation and integration, and again the integration. So what do we get? 1 dot dx is x only, integration of 1 is x, and under root a square minus x square is untouched. Now this d by dx of under root a square minus x square that we are going to do. Now under root x differentiation is 1 by twice under root x, you already know that. So we can just write it as, after differentiation, 1 by twice of under root, what is there? A square minus x square. But we need to differentiate a square minus x square also. So when we differentiate a square minus x square, a square is a constant, it will go 0, and negative x square will give you negative 2x. So you can write negative 2x here. How about integration of 1 dx? This will be x only. So let's write x here. Now this x into x, I can just write x square here. It can be written in the next step, but you understood now. So it is x square, x into x. Now we need to integrate this second part. First part is already done. So this 2 will get cancelled, but will not do anything with this negative sign. So negative x square divided by under root a square minus x square, I am explaining it separately. Now you know this a square minus x square is in the denominator, you need a square also in the a square minus x square in the numerator. For that, add a square and subtract a square, and then separate these two terms. A square minus x square is the first term, and second term is negative a square. So a square minus x square divided by under root a square minus x square will take as the first term, and then minus integration of a square divided by under root a square minus x square will be taken as the second term. So this minus, sometimes we are tempted to just take it outside and make it as positive. But here, this is not the case. You need to keep this negative in order to make it a square minus x square like that. Now we need to replace it here, because actually the second part I told you, and there is a negative multiplied. So I'll just multiply negative and then replace it. So when you multiply this negative, the sign will get changed. So we have x under root a square minus x square as the first one, which is already unchanged. And then we have this whole, which I explained you separately. This you can place it here. But before going that, we can simplify it more. Because a square minus x square to the power 1 divided by under root a square minus x square. Under root a square minus x square is a square minus x square to the power half. You already know that. So this base is same. So this half will go up. So it will be like x to the power 1 into x to the power negative half. So it will be x to the power half like that. So it will be under root x. And what is x? Under root, this is a square minus x square. So you'll get a square minus x square and to the power half, and this half is nothing but under root, which I told you in the beginning. So under root a square minus x square can be written in this place. Alright? So you have minus, and then you can write this. There is an integration also, right? A square minus x square under root a square minus x square. Let me write it like this. Then we have this a square by under root a square minus x square. So a square you can take common. So plus a square you just take outside, and after this integration you have 1 divided by under root a square minus x square. Now we have a direct result. See, there are two things which need explanation here. First is under root a square minus x square is the actual term from where we started. It is I only, from here only we started. So you can just replace under root a square minus x square integral as just I. So just write x under root a square minus x square. In this place you just write I. and I is on the left side also, and plus a square. Now this one I was telling you that 1 by under root a square minus x square is nothing but sine inverse x by a. It's just sine inverse x by a. You just write sine inverse x by a here. Sine inverse x by a. Okay, this negative I can be taken on the left. So I minus I, that is actually I minus I, when you take negative on the left hand side, it is I plus I. So it will be twice I. So 2i will be equal to, now I have already taken this out. So x under root a square minus x square plus a square sine inverse x by a. Now we have a 2 on the left hand side. So just take these 2 downstairs on the right hand side. So we have x by 2 under root a square minus x square plus a square by 2 sine inverse x by a, which is the second term of the result which I showed you earlier, plus a constant of integration. So this is your final result and proof of this expression or result.